Hi professors, my name is SieSiongWong. I'm going to present my final exam solutions. First of all, these are the packages I will load to solve the problem number one and number two. And those packages are the tidyverse, the mask, side, or caret. So for the problem number one, it's asking to generate the 10,000 random uniform number from n1 to n, and so for y as well, 10,000 random normal number with these equations. And so for the part ones, here I'm using the run if functions to generate the 10,000 random number for S and R known functions to generate the random number for Y and save those into a data frame with the column S and Y. And for part number two, I using the quantile function to get the median of S and Y variable and for calculating the probability of the from part A to C. First thing that I do is like from the data frame that I generate above, like filter like the big S greater than small s and big S greater than small y, and then count the row and then divide by total number of n, and then also like do the probability of the big S greater than small y, and then divide by the total number of n, and then finally divide this the first probability by the second probability, and this will give me the value of 0.549 for this question. And then for the next part B, I simply just filter again with the big S greater than small s and then big Y greater than small y, and then count the row, divide by n, and this giving me the probability of 0.377 for the you know for the probability of big S greater than s and big Y greater than small y. And for the part C, I do the same way, filter again for the S uh, less smaller than the small s, and then big S greater than small y, and then count the row and divide by n, and then do the same for the probability of S greater than small y, and then divide the first probability by the second probability, and this give me the 0.45 probability. For the part three, at first I mutate, the data frame into like the S, bs greater than small s and bs less than s, uh, for the column A, and for the column B, I do the same for the Y variable, and then do the count for each category and add the another column for calculating the probability um, for each category, and that will be my joint probability. And for the marginal probability, I simply ungroup from the joint probability data frame and do the sum of the probability for each type of A and B column. And for creating the table, I just bind the probability that I calculated above for the joint probability A B and the marginal probability A and marginal probability B, and then deselect the count and then spread the column A and then do the probability, and this will generate the column for me. Um, and then to determine whether the probability of s big S greater than s and the big Y greater than small y equal to the probability of big S greater than s times the probability of big Y greater than small y. And from here the result, you can see that there's only the decimal point 0.001 difference, so you can conclude that they are the equal. Basically, they are equal. And for the part number four, the Fisher exact test is used when there is a small sample set, and the Charles square test is used when the sample set is large. Thus, I would say that the Charles square test is most appropriate in this case here. From the result, we can see the p-value for both of the tests has much higher than the 5% significant level. And this indicator we cannot reject the null hypothesis. Thus, the independent hold for the two variables x and y. Now we can move on to the problem number two. So first of all, I download the data from the kaggle.com and save it in my GitHub repository. I load the data, into the R from accessing the, my GitHub repository for this class, and then for both of the train and test data for the house price data. And for the section of the discrete and inferential statistic, first of all, I just do the string function for the house price train, and then just want to see like, the such as the number of the observation and data type for each column. And, there's a, 1400, 1460 observation for each of the 81 variable. So, if I want to buy the house and live myself, I will adjust the sale price based on, some of these key factors, such as the overall conditions, overall quality, lot area, and etc. And for this exercise, I will just choose the following variable as a dependent and independent variable. So for the independent variable, I choose the lot area, overall condition, and overall quality. And for the dependent variable, the sale price, and and then I'll do the summary statistic for each of the independent and dependent variable. And from here, we can see that the lot area have the higher right skew value, and this is very obvious. We can see that from the histogram here. Um, from the scatter plot, the scatter plot of the sale price versus the lot area, we can see that many same lot area but higher price. This could be due to the factors such as the location, quality, and so on. And this is quite obvious, shown in the sale price versus quality plot. The house price is higher when the overall quality is higher. However, we don't see this trend happen to the overall condition variable. It doesn't seem like the overall conditions have much effect to the sale price, and we can judge this later on in the regression model. Next question is asked to find the correlation metric, and I use the code functions to do that, and I use the code test functions to do the hypothesis test here for the three independent variable versus the sale price. We can see that the p-value for each of the pairwise is the much less than the zero point 0.2 significant value, and this indicate that it is statistical significance. Therefore, we can reject the null hypothesis, and we can say that the change in the predictor's value are related to the change in the response variable. And from these three response variable, the overall quality variable have the stronger relations shift with the sale price. It has the point 0.9 0.71 correlations value. This makes sense as the overall material and the finish of the house is the single most important factor for determining the sale price of a house. And experience real estate agents will tell you in front the reason why a house is higher than the other, even though they look the same. And regarding the family-wise error rate, is the probability of a coming to at least one false conclusion in a series of hypothesis tests. So in other words, this is the probability of making at least one type 1 error. A type 1 error is the incorrect rejection of the null hypothesis test. So I don't think I would worry about family-wise error because this type of exercise, a lot of things are just common sense. And for example, we know that the bigger lot area will definitely have a higher price. If we are comparing, apple to apple, Uh, it's just a matter of how strong the relationship is, and that's just my opinion. Uh, uh, Regarding for the next part, is about the linear algebra correlations. I'm using the solve functions to find the precision metric. We can see that multiplying, the correlation metric by the precision metric, returning a diagonal metric. For doing the LU decomposition, I use the LU dot decomposition function to do that. Next is about the calculus-based probability statistic uh, solution. Um, I choose the log area variable for this question as it is the most right skilled and need not to shift as its minimum is above but positive, as you can see here. As mentioned in the question, like using the fit these functions in the math package, I mean for calculating the exponential probability density function, the optimal value is simply just a 1 over lambda. Um, we can see that from the histogram of the 1000 sample of the lambda is much spread out compared to the original uh, log error data. And also, like the empirical fifth and the 95th percentiles are are quite different than the confidence interval calculated while we assuming it's normality. So the log area variable is not normally distributed. However, the range on the empirical value are within the 95% confidence interval. The last part is the modeling. First of all, I just do the model, the linear regression model by the sale price versus the overall quality, overall condition, lot area, and so on. And from here, we can see that the overall conditions, the p value is much higher than the significance level, and so that means that it's not statistically significant, so we can remove the variable from the model and just review the model again, as it doesn't have a much effect to the model when the p-value is greater than a significant level. And after I review the model without the overall quality overall condition variable, uh, and and the R values seem to be improved a little bit. It's not that much, but overall the R value is good enough. Uh, and it's 0.658. And this means that 65.8% of the data variation is explained by the model. And the p-value of model is also much smaller than the zero point zero 0.05 significant level. This indicated the sample data provided enough evidence to reject the null hypothesis for the entire population, and the model fit the data better than the intersect only model. And this suggests that there's a strong relationship between the change in the two variables, the overall quality, log area, and the shift in the sale price variable. For a good model, typically we like to see the standard error that is at least 5 to 10 times smaller than the corresponding coefficient. And from this model, we can see that the standard error for all the variables, including the intercept, at least is 5 times smaller than the corresponding coefficient. And this last ratio means that there's a relatively little variability in the slope and intercept estimate. Right now, we can move to the next step, like doing the residual analysis to check whether the basic assumption of the linear regression is met, and we can quickly see it here. Um, you know, um, you know, we can see that residual plot it looked to be a heteroscedasticity, and we can see the residual are not uniformly scattered above or below the zero, and the residual tend to increase if we move to the to the right, and it looked like a cone shared pattern. So the vertical range of the residual increase as the fit value increase, but the histogram look it doesn't seem skilled. Mm, and but the the maybe I need to adjust a little bit, make it zoom in a little bit, and we can see very clearly. And but the QQ blog shared a heavy tier, and in the end. Anyway, we can rectify this problem, the heteroscedasticity, by using a method such as box cost transformation. You can see that after I, doing the transformations, we can see that the problem of the uh, heteroscedasticity have been rectified. With the new model, I use the predict functions um, to predict the sale price for the test data that which I loaded at the beginning, and then I save it the result to a CSV file to submit to the kaggle.com, and my score after I submitted, and I got my score as a point 21829. And that conclude my presentation of my final exam solutions. So I will post this the YouTube link here in the presentation session after I done this presentation. And and lastly, thank you, Professor, for teaching us this semester. I'm so great that to have you teaching us this class. I learned so much, and I hope that in the future I will have a chance to take your class again. Um, Thank you, and Merry Christmas and Happy Holiday. Thank you.